This presentation outlines the process in the design of a steel portal frame and the structural analysis undertaken. We will explain about the materials chosen and the structural measurements to meet both the client's needs and the relevant Australian standards and building requirements. The portal frame was designed as per the client's specifications. The design brief we received requested a steel portal frame of 32 metres in length, 18 metres wide, 7 metre eave height and a roof pitch of 6 degrees. The rafter loading was also specified to be 10 kilonewtons per metre.
Our structural design used flooring which is a combination of 400mm thick concrete slabs. Our frame was created with 406 by 178 by 60 universal beam columns and 356 by 127 by 33 universal beam rafters. Purlins code C15024 were placed on the roof with a spacing of 5.33 meters. Girts code C15024 were placed on the sides, and both of these members were secured by cleats which were 75 by 15.0 by 8 millimeters. In the exterior design, the walls were Lisag spandex which had a width of 24 millimeters. Between the roof and the walls were facade purlins. The roof was a Cliplock Classic 700 which had a thickness of 40 millimeters. 10 double hung windows were used, with 3 on the ground floor and 7 on level 1. All were placed near the mezzanine level. 2 doors were placed at the front east side of the project, one being a 2435 by 1981 overhead rolling door and a standard entry door which was a single steel frame, code AUS 820, was also placed.
The Australian standard AS4100 and the Wind Steel catalogue were applied for the portal frame design to meet the client requirements. The size of the rafters and columns were determined using table A1 from the structure steel catalogue as seen here. Purlin spacing was set by the requirements of the roofing materials used in the user guide. The last sort Cliplock Classic 7100 was used as a guide in relation to using 0.42 BMT roof material. The purlin and girt spacing depends on frame location, wall cladding spacing and roof sheeting. The girt and purlin size were chosen for a 5.4 meter span and a 1 kilonewton per meter wind load. The use of the Z15012 beam meets the criteria of the project. However, with anticipation of extra loading, a higher safety factor was required, hence the choice of the Z15024 beam. The girt size is a direct correlation with the purlin space sizing due to the same inward and outward loads applied to both. Since the girts have been selected using the same process as the purlins, the structural design will require light gauge steel C15024 beams.
In the design, the spacing of the columns are 533 meters apart, making it sit within the client's specifications and also giving it the strength and rigidity required to handle the crosswind and forces that will be experienced by the structure. On the eastern facing, there is 2 windows and a standard sized door, as well as a roller door. As we begin to rotate around the structure, we see that the windows are around and above the mezzanine to provide the workspace with natural light where the office is usually located. The mezzanine is 4 meters above the ground level, which provides it with sufficient working room under and around. The mezzanine is also supported by 4 columns and tied to the surrounding portal frame to give it the structure it needs to hold the weight that will be experienced on it.